We're going to do example 1 for the law of cosines. So we're given three sides, A equals 10, B equals 5, C equals 8, and we're going to solve triangle ABC. So uh, again, the hint that it's law of cosines is that this is example 1 from law of cosines, but there's other reasons. So I always draw like a random crappy triangle. It's usually equilateral by accident with an A and a B and a C, and they don't have to be accurate at all. This is not to scale, right? My B is 5, right? My A is 10, and my C is 8, right? So just to kind of help me visualize, right? So again, this is not to scale. I pretty much always draw the same roughly equilateral triangle, whatevs. Okay, so I don't know big A. I don't know big B. I don't know big C. I do know little a is 10. I know little b is 5. And I know little c is 8, right? So I need to find one of the angles, and then once I have one angle, I have some options, right? So what I'm going to do is I'm going to just go for the biggest angle. That's usually my approach, is to just go ahead and find the biggest angle. I know the biggest angle is going to be opposite the biggest side, so I'm going to try and find angle A. So I know that the law of cosine says that the cosine of A equals b squared plus c squared minus a squared over 2bc, right? Where b and c are the not a stuff, right? So I know that I could type in that a is the inverse cosine of, and then I'm just going to type in this stuff, right? So 5 squared plus 8 squared minus 10 squared, whole thing in parentheses, all over a 2 times a 5 times an 8, right? And this is one of those things that's kind of worth making a program in your calculator for, because because it comes up enough, and it's nice to have a formula in or a program in your calculator. So I'm assuming I'm in degree mode because most of these problems are. So I'm going to do the arc cosine, right, of, in parentheses, 5 squared plus 8 squared minus 10 squared, close the parentheses, divided by 2 times 5 times 8, close the parentheses. And so that's my angle A, right? I'm not surprised that it's a big angle. 97 degrees is a big angle. It's obtuse because I picked the biggest angle, right? I picked the biggest side, so that's the biggest angle. And I'm going to store that as alpha A because I'm going to need it again. So I get that this is a 97. So I'm going to go ahead and change that to a squiggle for approximately 0.903 degrees. And I'm going to note to myself that I stored it as A. Now, I have some options here. And it's entirely up to you which option you pick, because although this is a law of cosines problem, no one says you have to do the law of cosines for all the angles. So there's a few ways to do this. One option is to now use the law of sines, because I now have a pair, so I can use the law of sines. Now, me personally, I'm not going to do that, and I'm going to show you why. I have a particularly lazy way to do this problem. It's not wrong at all to say, hey, I'm going to do a pair with A and do law of sines to find B, and then once I know big B, I could subtract from 180 to find C. All of that is fine. However, I am a lazy, lazy human. So here's what I'm going to do. I'm going to recognize that I know this formula works exactly the same for all of the angles. If I wanted to find angle B, for instance, I would type this in, but what would happen is the thing that gets weirdly excluded is always the B squared, so the 5. So I'm going to type in inverse cosine of everybody but the 5. So 10 squared plus 8 squared minus, hey, there's the weirdo, there's the 5 squared, right? Divided by 2 times 10 times 8, right? Not the 5. And I could do the same thing for C, except the one that gets left out if I do C is the 8. So I do the inverse cosine of the 10 squared plus the 5 squared, and then minus the, oh, there's the solo weird 8 that gets left out, divided by 2 times 10 times 5, right? Because the 8 was the one that got left out. And here's the crazy reason that that's totally worth doing here. Because you can hit second enter on your calculator. Now I'm going to have to do it twice because I stored that thing as A. So I'm going to hit second enter, and I can just go ahead and change the numbers now. If I want B, I need to change that 5, right? It was a 5, I need to change to a 10. I need to change what was a 10 to a 5, right? So I'm going to go ahead and put a 1 and then second insert 0 to make that 5 into a 10. I'm going to put a delete the 1 and make that 0 a 5. And then down here I'm going to make this 5 into a 1, second insert 0. Boom, there's my angle B. So I don't even have to bother to store B because I've already used all I'm going to have to use, right? It's a 29.686 degrees, and I changed that little equal to a squiggle because it's approximate. And then I'm going to hit second enter one more time, second enter. And now I'm just going to change anywhere I saw a 5 into an 8 and vice versa. So now that's an even easier change because it doesn't involve inserting any numbers. So anywhere I saw a 5, it's going to be an 8 and vice versa. And I'm going to hit enter, and oh, look, there's my angle C, 52.4 0.10 degrees. Now, I changed that to an approximately, and it is worth a quick double check, right? You might want to just do a quick double check that those things add up to 180, but you can see by visual inspection that this is just a little bit, over 70, 81. Yep, that's a little bit over an 80, and that's a little bit under 100. Hey, there's your 180.